The Nobel Prize in Chemistry 2022 was awarded to Carolyn R. Bertozzi, Morten P. Meldal, and K. Sharpless for the development of click chemistry and bioorthogonal chemistry. I have heard about organic, inorganic, or physical chemistry, but what is this click chemistry? Put simply, it is a set of chemical reactions that are fast, efficient, and reliable. It is like Lego for molecules. Just like how you can easily snap Lego pieces together to build something, scientists use click chemistry to connect molecules in a simple and efficient way. Here's how it works. Imagine you have two molecules and you want to stick them together to create a new, bigger molecule. Click chemistry provides a set of easy-to-follow instructions, almost like a special type of puzzle piece. These instructions help the two molecules snap together in a precise and reliable manner. It is used in many fields like making new medicines, designing materials, and even creating colorful dyes. It's like a universal tool that makes it easier for scientists to build and connect different molecules to create useful stuff. Second new term is bioorthogonal chemistry. It is a type of click chemistry that can be used to modify molecules inside living cells. I'll explain it in simple terms. Imagine your body is like a super busy city with lots of traffic. Bioorthogonal chemistry is like a special type of roadwork that happens in the city without causing any traffic jams or disruptions. In our bodies, there are lots of chemical reactions happening all the time. Some of these reactions are crucial for our health, like making sure our cells get the right nutrients. Now, scientists want to study and control these reactions, kind of like being traffic cops in the busy city. This chemistry allows scientists to create small, safe detours or pathways that don't interfere with the regular traffic. It's like building a secret tunnel under the city so that important packages can be delivered without causing any traffic jams on the main roads. Okay, that is more than enough about the subject. Let's talk about the masters of the trade. We begin with Carolyn Ruth Bertozzi, an American chemist and a Nobel laureate. She is a professor of chemistry at Stanford University and an investigator at the Howard Hughes Medical Institute. Bertozzi is known for her work on bioorthogonal chemistry, a field that develops chemical reactions that can occur inside living organisms without interfering with normal cellular processes. Born in Boston, Massachusetts in 1966, she studied chemistry at Harvard University, where she received her bachelor's degree in 1988, and went on to earn her doctorate in chemistry from the University of California, Berkeley, in 1993. Bertozzi's doctoral thesis focused on the development of new methods for synthesizing complex carbohydrates. After completing her PhD, Bertozzi worked as a postdoctoral researcher at the University of California, San Francisco, where she began to study the role of carbohydrates in cell biology. She is a pioneer in the field of bioorthogonal chemistry and has developed a number of new chemical reactions that can be used to study and modify molecules inside living cells. Her work has led to the development of new diagnostic tools and therapeutic agents for a variety of diseases, including cancer and infectious diseases. One of Bertozzi's most notable contributions to the field of bioorthogonal chemistry is the development of the copper-catalyzed azide-alkyne cycloaddition, or CuAAC reaction. That's a name, or definition. Don't know. That's just lazy naming. This is a fast and efficient chemical reaction that can be used to link two molecules together. She has shown that the CuAAC reaction can be used to modify a wide variety of molecules, including proteins, carbohydrates, and lipids. She has used this reaction to develop new tools for studying cell biology and disease. For example, she has developed a technique called bioorthogonal imaging, which uses the reaction to label and image molecules inside living cells. Bertozzi has also used the CuAAC reaction to develop new therapeutic agents, such as cancer-targeting drugs and antiviral drugs. She is a strong advocate for science education and outreach. She has given numerous public lectures and interviews about her work, and she has written several popular science articles. She is also a member of the board of directors of the American Association for the Advancement of Science. Secondly, we have Morten P. Meldal, a Danish chemist, who won the 2022 Nobel Prize in Chemistry jointly with Carolyn R. Bertozzi and K. Sharpless for the development of click chemistry and bioorthogonal chemistry. He is a professor of chemistry at the University of Copenhagen in Denmark. He is best known for developing the CuAAC click reaction, concurrently with but independent of Valerie Fee-Foucault and K. Barry Sharpless. He was born in Copenhagen, Denmark in 1954. He studied chemical engineering at the Technical University of Denmark, or DTU, where he received his bachelor's degree in 1978 and his master's degree in 1981. He then went on to earn his doctorate in chemistry from DTU in 1983. His doctoral thesis focused on the development of new methods for peptide synthesis. After completing his PhD, Meldal worked as a postdoctoral researcher at the MRC Laboratory of Molecular Biology at the University of Cambridge, and later at the University of Copenhagen. In 1996, he returned to DTU, becoming a professor there. He is best known for developing the QAAC click reaction, concurrently with but independent of Valerie Fee-Foucault and K. Barry Sharpless. The reaction has been used in a wide range of applications, including drug discovery, material science, and biotechnology. Meldal has also made significant contributions to the field of bioorthogonal chemistry. It is a type of click chemistry that can be used to modify molecules inside living cells. Meldal has developed a number of new bioorthogonal reactions, which have been used to study cell biology, disease, and drug delivery. He, too, is a strong advocate for science education and outreach, and has given numerous public lectures and interviews about his work, and he has written several popular science articles. He is also a member of the board of directors of the Danish Academy of Technical Sciences. Finally, we have K. Barry Sharpless, an American chemist who has won the Nobel Prize in Chemistry twice, in 2001 and 2022. Can you name another such personality that has received a Nobel twice? He is known for his work on click chemistry and bioorthogonal chemistry. He was born in Philadelphia, Pennsylvania in 1941. He studied chemistry at Dartmouth College, where he received his bachelor's degree in 1963. He then went on to earn his doctorate from Stanford University in 1968. His doctoral thesis focused on the development of new synthetic methods for the preparation of natural products. After completing his doctorate, Sharpless worked as a postdoctoral researcher at Harvard University. At Harvard, he began to study the mechanisms of organic reactions. In the early 1970s, he joined the faculty of the Massachusetts Institute of Technology. At MIT, he began to develop new methods for asymmetric synthesis. It is a type of chemical reaction that produces only one enantiomer of a product. Enantiomers are molecules that are mirror images of each other. Well, I shall cover them in detail in some other series on organic chemistry. Sharpless's major scientific contributions include the development of click chemistry and bioorthogonal chemistry. He is also known for his work on Sharpless epoxidation and dihydroxylation. These are two chemical reactions that are used to synthesize a variety of organic compounds. Every time I learn a new term, the itch to know at least something on that never leaves. Let's look into them very briefly. Sharpless epoxidation is a chemical reaction that involves adding an oxygen atom between two carbon atoms in a molecule, forming a three-membered ring called an epoxide. It typically uses a catalyst, a special substance that speeds up the reaction, to selectively create this epoxide ring without affecting other parts of the molecule. It is valuable in organic chemistry because it allows scientists to create specific structures in molecules, which can be used in the synthesis of various compounds, including drugs and complex organic molecules. Let's talk about dihydroxylation. It is a chemical reaction that adds two hydroxyl OH groups to adjacent carbon atoms in a molecule. Like Sharpless epoxidation, dihydroxylation often involves the use of catalysts to control the reaction and ensure that the hydroxyl groups are added at the right positions. It is essential in organic synthesis because it allows chemists to create molecules with two hydroxyl groups in precise locations. These molecules can serve as building blocks for various products, including pharmaceuticals and specialty chemicals. Moving back to K. Barry Sharpless. He is one of the most influential chemists of our time. His work has revolutionized the way that scientists can create and modify molecules. His discoveries have led to the development of new drugs, materials, and diagnostic tools. Sharpless is also a highly respected mentor and teacher. He has trained many students who have gone on to become successful scientists in their own right. Make sure to subscribe to never miss an update. Check our podcast series that contains a detailed analysis of every Nobel winner to date. Well, we are updating it frequently.